Hi, this is Mr. Max. So I'm doing question 7 due to a request. So it says the diagram below shows the front view of a house with a roof of PQR, this triangular roof here, and a wall of QRST, this rectangular uh, wall there. The height of the wall is 3.4 meters, as you can see, and the length of the wall is 9.6 meters, as you can see. Then the angle of elevation of QP, this angle of elevation from QR is 50 degrees, and then the length of PQ is 4.8. They want us to calculate the height of P above ground level TS. So what that means, it means that we are looking for this whole distance over there. But we know something. We know that the distance from here to here is 3.4 meters. It's corresponding with that distance over there. So in a nutshell, we are supposed to find, let's say, this distance over here. And then if we can determine what that distance is, we're going to add it with this 3.4 in order to find the height of P. So that will be 3.4 plus what we are going to calculate. Right, so I just want to bring in the right angle triangle that I have. I'm just going to draw that with my free hand. So the right angle triangle, this one over here, we know that that is 90 degrees. We know that this is 50 degrees over here. We know that that distance is 4.8. I'm looking for that height. In order for me to calculate that height, I'll have to use my sine ratio, because sine of 50 degrees is whatever is opposite that 50 degrees divided by the hypotenuse. The hypotenuse is the longest side of a right angle triangle, and it's always opposite the 90-degree angle. So, and that is going to give me h over 4.8. So this is a calculated value, and you're going to multiply 4.8 with that calculated value. All right, and you are going to find what is the value of h. So let's grab our calculator, and if we do so, just make sure that your calculator is in degree mode. Okay, there should be a DEG or a D displayed, otherwise it will not be in the correct mode. So this implies that I should say 4.8 multiplied by, there's no need to write the multiplication if you put the 4.8 behind the sign ratio, okay, the sign of the angle 50 degrees. So you get 3.677. So I'm going to write that in here. So that's 3.6770, 1, and so on. Since it's still programmed on my calculator, I'm just going to add the 3.4, add 3.4, so that answer 7.0. So it's 7.0, 770, So ultimately, to three significant figures, this answer that I was required will be 7.08 meters. Okay, that is to three significant figures. Now they ask me to find PR. So what I'm going to do is I'm just going to draw the triangle again, and I'm going to have my 4.8 like so, and this was 50, and I'm going to put an X here for this distance, and I'm going to go back to my diagram to show you exactly why I'm doing that. So if you look at, and I'm just going to remove this because it's quite clear for you. If you look at the distance that we are supposed to look for, that is the distance from here, this is the required length that the question is asking us. We know what this is, but I'm not going to use it. I want to find this distance over here, because if I do, I'll be saying 9.6 minus that x in order for me to find this distance. Okay, so once I determine what that distance is by saying 9.6 minus whatever my value of x would be, then I have got, I'm going to use that third side which I got before. So I just want to re-emphasize something there. That was 3.6770. That was like 3.67701, that distance. And then I'm going to, and remember this angle over here is also 90 degrees. And then I'm going to use Pythagoras's theorem when I'm looking for a third side given two sides. Okay, so let me first calculate what that value of x is. That's why I drew that triangle over there. And in order for me to find the value of x, I have to use the cosine of 50 degrees, because the cosine sees whatever is adjacent to the angle, in this case of x, divided by the hypotenuse, which is 4.8. So 4.8, we can think of that as cross multiplication times that is going to give me my value for x. And if I go and I get my calculator, I'm going to say, and this is what you can do. If you press cosine of 50 degrees first, put it in brackets, and then you must press multiply by 4.8. Otherwise, if you put the 4.8 in front, you don't have to put multiplication. So this is 3.085. So this is 3.085. Just want to 380. So this is that distance x, the one that I've indicated. So what I want to do is I want to subtract 9.6 minus that. So I will be saying 9.6 minus this answer. Okay, so you can see that I'm not using rounded answers. Okay, that gives me 6.5146. So it's 6.5146. And so on. So now that I know what that distance is, I have a new right angle triangle. Perhaps I just have to bring it in here. So my new right angle triangle is now this 6.5146. This value that, remember, I am now, this is the height. I'm now on this side of the right angle triangle. This is the right angle triangle that I'm using, 3.67701. So this here is 3.67701, and that is right. And I'm looking for this distance here, which is PR. Okay, so I'll be using Pythagoras' theorem. So I'll just write it underneath here because I don't have space. So PR squared is equal to 6.5146 squared plus 3.67701 squared. And if you want to find PR, you take the square root of whatever that answer is. Okay, so I'm going to do my best to put all of that and to work it out. So I have got 6.5146 squared plus, because we're looking for the longer side, and if you look for the longer side, you must add. Okay, just excuse me there for pressing the wrong. Then it's 3.67701 squared. Bear with me. So we are going to hit equal to, so that is 7.8066. So it's 7.80669 and so on. Then to three significant figures, it's going to be 7.81. Okay, so that does it for us to find those two distances that was required. Of course, gives you answer to three significant places or three significant figures. Question 8, the diagram shows the line AB. The coordinates of A is 4, 0. The coordinates of B is 0, -6. They want you to find the equation of the line. Of course, the first thing is you need to calculate what is the gradient of AB. That will be delta y over delta x. You take two y values, you subtract them from each other, and you take two x values and you subtract them from each other. Doesn't matter, but I want to start with point B, so that's going to be -6 minus 0. And I started with the y value of -6 of B. I must now also start with the x value, which is 0 minus 4. If you were to say 0 minus -6 and so on, you will still get to the same gradient. Okay, so in any case, we're going to have -6 divided by -4. Just remove those zeros there. Then 6 over 4 is nothing but 3 over 2 or 1.5. So I'm going to leave it as 3 over 2. Now, there is a formula that I wish you are familiar with, but suppose you're not familiar with that formula. Okay, so you have got y equals to mx plus c, and you know the gradient is 3 over 2x, and you can see that the y-intercept here is at -6. So this becomes 3 over 2x minus 6, but we don't leave the answer in this form. So what we are going to do is we are going to multiply. Let me just write my x so that you don't get confused with what I'm going to do. So I'm going to multiply every term here by 2. That means I'm going to multiply here by 2, this by 2, and that by 2. That is to clear the fraction. So it's 2y equals to 3x minus 6, not 6 but minus 12 now, because 6 times 2 is 12. And we have to write it in that form. So it means that this 2y should go over. So it's 0 equals to, then you have 3x. Oops, let's just write our 3x nicely. So it's 3x minus 2y minus 12. Ultimately, you can write it as 3x minus 2y minus 12 equals to 0. There's another way, and hopefully you can find it on how to rewrite that. But ideally, I'll say stick to the basics, and you are not going to have much of a problem. Okay. In any case, you have y minus y sub 1 equals to m over x minus x sub 1. This is if you have a point, say for example, any one of the points 0, -6, or the other point which is 4, 0, and you substitute the x and the y value there, but you are supposed to first calculate the gradient in order for you to write that gradient in there. So your x value would be your 0, your y value here would be like your -6, and then you continue from there, and again you arrive at the same equation. Now they ask you to find the midpoint of point A and B, so I'm just going to write down what the coordinates of A is. The coordinates of A was 0, 4, and the coordinates of B, if you remember, 0, -6, so you can see right up here. The coordinate of A is 0, 4. So we're going to find the midpoint by taking the two x values and add them up. So we say, well, of course, I think this point here is supposed to be the other way around, which is 4, 0. Just make sure that you have it, 4, 0. Add the two x values. So we say 4 plus 0 divide by 2. and add the two y values, 0 plus -6. Then we're going to divide that by 2. Okay, some calculators maybe you put brackets there, but eventually you have 4 over 2 comma -6 divided by 2. Well, this is going to be 2 comma -3, and these are the coordinates of the midpoint. So basically the midpoint is going to be somewhere on this line here. That's the midpoint, and we now know the coordinate is 2 comma x will be 2 and y has to be -3 somewhere over there. So there is now another part to this. There is a line that is going to that we are looking for, and this line is called the perpendicular bisector. Okay, perpendicular bisector. So the line and our point in here, they meet at this point, which means this point 2 comma -3 I'll use. So I'm going to write that point down, the midpoint. So I need that midpoint. I'm going to call it M, 2 comma -3. But one thing that you should know about perpendicular lines is that their gradient, so the gradient of our line AB times the gradient of the perpendicular bisector of AB should give you -1. We know what our gradient of our line is. The gradient of our line was from before, the gradient of our line was 3 over 2 or 1.5. So this 3 over 2 here multiplied by something should give you -1. Well, that something will be the reverse of 2/3. So it is 3 over 2. You swap it around because it's the only way you multiply any number or any fraction by its inverse, you get 1. And this is a positive, so our answer should be negative. So we now know what is the equation. So the equation is y equals -2 over 3x. But I need to calculate the value of c in that equation. So y equals to -3x plus c, -3 over 2, my goodness. So that's -3 over 2x plus c. So now I'm going to substitute this midpoint for x and for y. So y being -3 equals to -3 over 2, x being 2 plus c. In order for me to calculate what that value would be, the 2 cancel here, all right, and they have -3, and remember you have a -3 over here, so you're going to have that -3 plus c, right? So obviously c will equal to 0 if you bring it over there. So my line that I drew there did not really do justice to how this line would be going, but what is important for you to remember is that it will now pass through this line. Let me just remove it just to have an idea. Our line that we are looking at, this line will pass through the origin and it will be somewhere like that. Remember, these diagrams also are not to scale, and the point of intersection here is perpendicular bisector. It's 90 degrees and it cuts that line in half. So that is the line that we just calculate the gradient of. Right, suppose someone said, okay, I know the gradient now. I think there's a small little problem. I just want to see our gradient was 3 over 2 and not -3 over 2. But wait, so this is supposed to be 3 over 2 and not -3 over 2. Having said that, that gives you a different value for C if I substitute that in there. So our C, all right, my apologies, 1,000 apologies, will be -9, okay, because that 3 goes over, becomes a minus. So our C equals to -9. So our equation here, to just rewrite it properly, our equation is going to be y equals to 3 over 2x minus 9. So that takes care of that one there. So I have to go back and also sort of rectify that. The perpendicular bisector, minus 3 minus 9. X is 2, y is negative 3. Negative 3 equals to that times that. So if you are cancelling out, you have a 3, and that 3 comes over the next side, which is minus 9. So C is minus 9. I guess in this line, the perpendicular bisector is going to be cutting the y-axis at minus 9, and that is now something that I want to look at. The gradient of that line should definitely not be 3 over 2. Okay, let me just go back, and please, 1,000 apologies, because I just decided to do this question just out of the blue. There's something that I just realized, a small little mistake. In any case, we're going to start over it. That if at first it doesn't work, then we have the gradient of our line. The gradient of our line is y equals to minus 2 over 3 rather, okay, plus c. And this is the line that is perpendicular that we are looking for. Now we're going to substitute our point for y, which is negative 3, and for x, which is 2 plus c. That's good. All right. So eventually, this is going to give you negative 3 equals to negative 4 over 3 plus c. That will give me that c will be negative 3 plus 4 over 3. Okay. If you grab your calculator, you have got negative 3 plus, well, 4 over 3. So that gives me negative 5 over 3. All right. So therefore, C is negative 5 over 3, which makes more sense. So the equation is y equals to negative 2 over 3x minus 5 over 3. Well, another person can be writing this equation also as, I'll just write it over here, y equals to minus 2x minus 5 all over 3. Or they could be writing it also in the other style, like what they requested in the previous answer here, when they were saying write your equation in that format. But there's no explicit instruction that say you should leave it in this format, so any one of these two will do. Okay, all right. Just remember, there's a few pointers and things you should remember when it comes to working with lines, whether they being parallel and so, and do work through this paper, and it will also assist you immensely if you were to say, for example, if you were to work with preparation for your exams and those kind of things. All right, just to emphasize, so that will be the point negative 5 over 3, the point that we just determined over here. That is going to be that point there, okay? All right, have a good day. Maybe I can do one more question. I can have a look. I see a speed time graph over here. This is also a very interesting question since I'm in the mood to do it, but maybe let's have a look at question 11. The diagram shows the surface area of a rectangular swimming pool, which is 10 meters long and 3 meters wide. The area is doubled by increasing the length and width by x, as you can see. Now they want write down equation in x if the surface area is doubled. So the equation in x is going to be, the area would be, of course, now it's not 3 anymore, but it's 3 plus x. And it's not 10 anymore, but it's 10 plus x, or you can have the other way around, okay? And the area of this, the area of this one is 3 times 10, which is 30. So if they say the area is doubled, double of that would be 60. So double of that is the same as 2 times 30. I'm going to rewrite it. They say write down an equation. I'm just going to write it as x plus 3. I'm just going to put the x's in front. plus x plus 10 equals to 60. Okay, so that is the equation. And now solve the equation. Of course, if you solve the equation, x plus 3 and x plus 10 equals to 60, you go ahead and you multiply out x squared plus 10x plus 3x plus 30 equals to 60. That is, if you multiply that binomial there, so you have got x squared plus 13x, and then minus, you have got 30 here minus 60 equals to 0. So x squared plus 13x minus 30 equals to 0. All right, so we have to now factorize and solve the equation over here. So the constant is a negative, so one value will be positive, one will be negative. So two numbers multiply to give you 30 or negative 30, and if you add them, they give you 13. So those numbers have to be 15 times 2, where the negative comes on the negative 2, right? So 15 plus negative 2 will give us negative, that gives us positive 13. So the numbers I'm looking for, 15 is positive, I put my 15 over here. The other one is negative, I put it over here. So x plus 15 equals to 0, or x minus 2 equals to 0. So x would equal to negative 15. This one is invalid because you can't have a distance here, cannot be negative, right? So the answer x equals to 2 is the answer that we are looking for, okay? Then they're asking you to find a new dimension. So the new dimensions will be x plus 2 more, which in this case, our, not x plus 2 more, but 3 plus x, or x plus 3, which is 2 plus 3, which gives me 5. And the other one was x plus 10, which is the same as saying 2 plus 10, which is obviously 12. And you can go ahead and look at 5 times 12 will give you 60. So the length is 12 meters. The width is nothing but 5 meters. Very interesting question, that also. Okay, so the space might not be enough, but you can make it work whenever you're solving that particular question. All right. Good luck with your studies. There's so much. Maybe question 13. The diagram shows the graph of y equals to cos x for values of x between 0 and 360 degrees. Write down the coordinates of q. Now, if you were to look at it nicely, this line will obviously be something like so. So the coordinates of q is the x value over here. So x is 180 degrees and the y value is nothing but negative 1. Find the value of cos 360. Of course, that means you go up here. Let's just change that color. From here to there, that is what we're looking at. And we're going to read down whatever that answer is. Of course, it's 1. So you're just going to use your diagram, and then you can be able to solve the question over there. So find the value of cos of 360. Cos of 360 degrees is equal to 1. In fact, you will get the same answer on your calculator. If you were to hit cos of 360 degrees, you'll get 1 as an answer. But you can use your calculator, your diagram, in order for you to do that. Okay, but say find the value, you can also use your calculator. For values of x between 0 and 360, find two values of x for which cos is negative a half. Now, here's the thing. Just to emphasize something, because we have to work it out, right? Negative a half is going to be somewhere over here. All right. So this here is negative 1 over 2. So we are looking for an angle here and here, what those angles would be, where the value of cos is negative. So I'm not going to talk about the first quadrant and the second quadrant, because you should know that and maybe perhaps I can have a look at it so that it can help you to understand a few things. If you were to look at the first quadrant, which is from here, the cosine graph is positive. So the ratio, whatever the ratio would be, will be positive. Let's give you an example. So if you say, let's say we punch in an angle, let's say 45 degrees, okay? Let's say or even 60 degrees for that matter. 60 degrees is going to be somewhere over there. The ratio here is positive, okay? So if we are going in the second quadrant is from 90 degrees up to 180 degrees. You can see that cosine is negative. If you go in the third quadrant, you can also see that the cosine is negative because the graph is on the negative side. And obviously, if you go to the fourth quadrant, you would see that cosine is positive. So what this is known as the cast diagram, just in short. So what it tells us, and it's written like this, cast. Here, the cosine is positive, and that is in the fourth quadrant, as you can see. Here, all the ratios are positive. That is the sine, the cosine, and the tangent. Here, sine is the only one that is positive. Here, tangent is the only one that is positive. So, in these two, the graph of cosine in the first quadrant and in the fourth quadrant are positive. So, we're not looking for that. We're looking for the angles in the second quadrant as well as in the third quadrant. So, in this is 0 here, or 360. This is 90 degrees, this is 180 degrees, and this is 270 degrees. So think of this as an angle that moves. Supposedly, your angle is over here. Okay, so weird way of drawing that. Right. So in the first quadrant, we already determined that it's positive over here. But if we move that to the second quadrant, so the angle that we are now looking at, the angle is going to be an obtuse angle. Can you see that in that quadrant? So in the second quadrant, it should be 180 degrees because it's obtuse. So it must be in the second quadrant. Our angle x would be 180 degrees minus, and I'm going to put theta over there. Okay. If I was to do the same and I move and I come to the third quadrant over here, the angle that we are now looking for, I hope you can see that. That angle is going to go all the way around like this. So that our angle has to be 180 plus. So the angle in the third degree has to be 180 plus theta. So what is theta? So as you can see, as I indicated here, the theta is this acute basic angle. So we're going to calculate that angle by saying, okay, let's find what is the inverse. Let's find our angle, acute basic angle. I'm going to use theta, the inverse cos of, but here you must put in a positive ratio. That one indicated to us that in the second quadrant and in the third quadrant, cosine is negative. Once we know what that angle is, that is the angle we're going to subtract from 180 or add to 180 in order to find the two values. And you will see that if I punch in those angles, you're going to get a negative result. So what that reference angle is the inverse cosine. The inverse cosine, you press that if you're looking for an angle of a half or 0.5 if you want to. That gives me the angle, which is obviously 60 degrees, as you have seen from our work before. So now I know that our angle is 180 minus 60 degrees, which is 120 degrees. The other angle will be 180 plus 60 degrees, that is 240. And clearly 240 is an obtuse angle and a reflex angle respectively, as you can see. So just check that if I was to press the cosine of 120 degrees, I'm going to get negative a half. So if I say cos of 120 degrees, I get negative a half. The same, if I was to press the cosine of 240, I'll get negative a half. And our diagram is quite clear in that regard. Okay, so these are the angles then here, 120 over there and 240 over there. They will have a negative ratio. Okay, so when you are doing trigonometry, maybe you should also be able to understand what the cast diagram is, although it's just something we use in mathematics to help us explain answers. Also worth remembering, this graph continues forever. It's periodic to the left, to the right, but the domain has been given to us from 0 to 360 only. So there are other solutions, but solutions that lie from 0 to 360 should be within. And clearly 120 and 240 are within the given domain. All right. Good luck with your studies. I hope that um, it will assist you. Maybe question 16. The sum, this I promise is going to be the last question. The sum of the interior angles of a polygon with n side is 3,600. So the sum of the interior angles of the polygon is 3,600. That is, we don't know this polygon. So we just know that, let's suppose I just draw a normal polygon so you can understand the concept, okay? So this here is an octagon. So when you are told the sum of the interior angles, these are all of these angles. The formula to calculate the sum of the interior angles of a polygon is 180 times n minus 2, where n is the number of sides. So if I want to find the sum of all the interior angles of an octagon, I'm going to say 180 in brackets 8 minus 2. That's 1008 minus 8 minus 2. So 1080. Okay. So this is the sum of the interior angles of these polygons. So we're going to say let it n equal to 3600. So we are told that it is equal to 3600. So we have to solve this equation. There are many ways you can do this. You can first of all say, okay, wait a minute, 3600 divided by 180, okay, I get 20. So I'm dividing throughout here. I'm dividing by 180, and I'm also dividing by 180. I have n minus 2 is equal to 20. Then n will be 20 plus 2, and therefore it has got 22 sides. All right, this is where I sign off. Um, please do ask the questions and you will definitely get assistance where it's required.